Okay, hello dear students, welcome back to the class. In the previous class, that means in the third video on study of first element hydrogen, I have explained you uh, the process of preparation of hydrogen gas by Bose process and by the method of electrolysis. Okay, and in today's class, you will learn to prepare hydrogen gas using metal and water, various forms of water, first cold water and then hot water and then steam. Okay, and for that metals will also have some criteria. So first I explained you about the laboratory method of preparation of hydrogen gas. That was number A. Number B, I explained you a Bose process for large scale manufacture of hydrogen gas. Number C, I explained you about this method of electrolysis for the preparation of hydrogen gas. And this is number D. Okay, so preparation of hydrogen gas from cold water and metal. See, before this you should know the reactivity series of metals. Reactivity series of metals. Okay, so first comes potassium. Okay, I'll write little smaller. Okay, I'll write here. Below this there is gold and below that there is platinum. Okay, so first is potassium, below that sodium, below that calcium, Ca calcium, after that Mg magnesium, Al aluminium, Zn zinc, Fe iron, Pb lead, H is hydrogen. H stands for hydrogen. Okay, after that copper, Cu stands for copper, Hg stands for mercury. Okay, Latin name of mercury is hydrargyrum. Next Ag is silver. Argentum, Latin name is argentum. Au stands for gold, Latin name is aurum. Pt stands for platinum. Okay, Pt stands for platinum. So this is the reactivity series of metals. So the metal, this is highly reactive, highly reactive, and the reactivity goes on decreasing when you move down to this uh, line. Okay, and this is the least reactive, reactive, least reactive metal. So first highly reactive is potassium, after that sodium, after that calcium, magnesium, and so on. Okay, now these three metals here to here. Okay, these three metals reacts with cold water, to give hydrogen gas. Okay, and this metal reacts with hot water. Magnesium reacts with hot water to give hydrogen gas. Okay, and the metal aluminium, zinc and iron reacts with steam, gaseous form of water. Okay, hot water, steam, to give hydrogen gas. So you should remember, first of all you should remember this reactivity series in sequence: potassium, sodium, calcium, magnesium, aluminium, zinc, Fe iron, Pb lead, H hydrogen, copper, Cu copper, Hg mercury, Ag silver, Au gold, Pt platinum. Okay, now preparation of hydrogen gas from cold water and metal. Active ACTIV, active metals, active metals, that is potassium, sodium and calcium, reacts with reacts, reacts with cold water, cold, cold water to give H2 gas as follows. Okay, let's do the reaction. Potassium plus cold water, H2O. Water should be in cold condition, cold water. Okay, gives potassium hydroxide, KOH, and hydrogen gas. This is hydrogen gas. Okay, so this will split, giving H plus ion and OH minus ion. Water splits by giving H plus ion and OH minus ion. So this potassium combines with OH negative. This is positive. Potassium forms positive ion. Okay, so this combines with negative ion and gives KOH. This hydrogen, it will combine with another hydrogen ion. Okay, and give hydrogen gas. In similar manner, sodium plus water. This is also in cold conditions. Same thing. Okay, gives sodium hydroxide, NaOH, plus hydrogen gas. Next, calcium, Ca, plus H2O. Condition is same, cold water. Okay, gives calcium hydroxide, CaOH whole twice. Here 2 comes, plus water. Okay, this 2 comes here because valency of calcium is 2. So cross multiplication takes place. Valency of OH is 1, so 1 goes this side, 2 comes this side. Here valency of sodium is 1, OH is also 1. So when you cross multiply, you will get 1 1. Potassium, it is 1, this is also 1. So okay, in formula of potassium hydroxide is KOH only. Sodium hydroxide is NaOH. But calcium hydroxide is CaOH whole twice. Okay, next, number E, preparation of hydrogen gas from hot water and metal. Okay, so metal, only this magnesium reacts with hot water. Okay, magnesium, Magnesium, magnesium reacts with hot water, HOT, hot water, to give hydrogen gas as follows. FOLLOWS follows. So magnesium plus water should be hot. Okay, so reaction is, it forms magnesium hydroxide, MgOH whole twice will be there, because valency of magnesium is 2. You know that we have done the names and symbols of chemical compounds in first chapter itself. Okay, so magnesium hydroxide plus hydrogen gas. Balancing, you can do it on your own. Balancing part, you can do it. So only magnesium reacts with hot water to give hydrogen gas. Okay, now next is number F. Number F, preparation of hydrogen gas from steam and metal. Here metal is, you have to use aluminum, zinc and iron. Okay, so aluminum, I'll write the symbol only, aluminum comma zinc and iron, Fe, reacts with steam. Steam means extremely hot. Okay, extremely hot water in the form of vapor. Okay, so nearly 800 degrees Celsius. Nearly 800 degrees Celsius. Zinc, aluminum and iron reacts with steam at 800 degrees Celsius. Okay, this is approximate temperature to give hydrogen gas as follows. So aluminum plus water is in the form of steam, and temperature is nearly 800 degrees Celsius. So it forms, instead of forming aluminum hydroxide, it forms aluminum oxide, Al2O3. Okay, plus hydrogen gas, because the temperature is extremely high. So aluminum hydroxide changes to aluminum oxide. Okay, next, aluminum is done. Now zinc plus H2O, this it is also steam. Okay, so zinc oxide ZnO plus H2 gas, hydrogen gas. This upward arrow shows gas. Okay, it indicates this is the symbol of gas, release of gas. Next you have Fe plus H2O in the form of steam, and temperature is almost same, this 800 only. Okay, so iron oxide Fe2O3 plus hydrogen gas. And remember here the formula of zinc oxide is ZnO, but the formula of aluminum oxide is Al2O3, and iron oxide is Fe2O3. This is because of their valency. Okay, see aluminum and oxygen. Aluminum, its valency is 3 plus, oxygen is 2 minus, so it gets cross multiplied. So formula becomes Al2O3. Formula of aluminum oxide becomes Al2O3. Whereas in case of zinc, ZnO, zinc, its valency is 2 plus and oxygen is 2 minus. This and this gets cancelled, so formula becomes ZnO only. Okay, and same thing happens to that iron oxide also. Iron oxide, ferrous oxide, Fe2O3 is ferrous oxide. Okay, so you should, in order to remember these reactions, first of all you should know this series, reactivity series of metals. Okay, first three metals are said as reactive metals, highly reactive metals. They react with cold water to give hydrogen gas. Next, magnesium reacts with hot water to give hydrogen gas, whereas this aluminum, zinc and iron reacts with steam to give hydrogen gas. Okay, now number Z. Okay, preparation of hydrogen gas from dilute acids. Here in place of dilute acid you can use HCl or H2SO4, or sometimes you can use nitric acid also. Okay, HCl is hydrochloric acid and H2SO4 is sulfuric acid. Okay, preparation of H2 gas from dilute acids by displacement method. For this also you should know the reactivity series. So reactivity series you have so the metals which lie above hydrogen. Okay, the metals which lie above hydrogen react with dilute acid to give hydrogen gas. Okay, so active metals, okay, otherwise metals which occurs, OCCURS, occurs above hydrogen. It's above hydrogen in ACTIVIT activity or reactivity series. REACTIVITY reactivity series displaces, okay, otherwise reacts with dilute acids like HCl and H2SO4 to give H2 gas as follows. Okay, so I'll give the reaction, okay, just below this. So potassium, okay, reactions, REACTIONS, reactions. Number 1, potassium plus, I'll give the example in HCl, okay, dilute hydrochloric acid. Next you have number 2, you have sodium Na plus HCl, dilute, this is also dilute. Next, number 3, you have calcium plus HCl, dilute. In similar manner you have this, after calcium you have magnesium, aluminum, zinc, iron, I'll give next number 4, you can do it on your own. Okay, number 5 till Fe you can show till Fe. Last is Fe. Metals which occurs above hydrogen only, you can do till Pb, lead. Okay, so metal plus dilute acid gives salt. Salt is sodium potassium chloride, KCl, plus hydrogen gas. This gets released. Next, sodium plus HCl will be sodium chloride, NaCl, plus hydrogen gas. Next, calcium plus HCl will be calcium chloride, Cl2, because the valence of calcium is 2. Okay, so H2 gas. Next, you have below calcium, you have magnesium, Mg. Magnesium plus HCl, acid. Okay, dilute, gives magnesium chloride plus H2 gas. Okay, you can balance this equation by putting 2 here. You can put 2 here and 2 here and 2 here. In this way you can balance. Okay, balancing is up to you. So I have not balanced any of the equations. Okay, so you can try balancing on your own. Next, you have aluminum. You can do this type of reactions. Okay, so metals which lies above hydrogen has the ability to remove or displace hydrogen from dilute acids like HCl and H2SO4. So in this way also you can prepare hydrogen gas. Okay, so active metals which occurs above hydrogen plus dilute acid. Dilute acid you can use HCl or H2SO4 or HNO3, gives salt. These are called salts. Okay, this column is salts, gives salt and hydrogen gas. Okay, now the last process for the preparation of hydrogen gas, number 8. Okay, preparation of hydrogen gas by displacement of hydrogen from alkalis. Alkalis means water soluble bases. Okay, so I'll give you the example of zinc reactions. I'll give directly. Okay, reactions reactions. Number A, zinc plus alkali, you can take sodium hydroxide, NaOH, or you can take potassium hydroxide. Okay, so this reaction goes like this. See, zinc cannot displace this sodium. Zinc cannot remove sodium and it cannot form zinc hydroxide plus sodium. This reaction won't take in this place. Okay, because this zinc occurs below sodium in reactivity series. See, zinc is less reactive than sodium. Zinc occupies lower position in the reactivity series. So zinc has no ability to remove sodium from sodium hydroxide. Okay, in place of sodium hydroxide, if you had, say, below this FeOH whole twice, iron hydroxide, then zinc hydroxide plus something iron, this type of reaction might take place. Okay, it will take place. Zinc has the ability to remove Fe, because zinc is more reactive than iron. So in place of FeOH whole twice, you have sodium hydroxide, NaOH. NaOH is alkali. Okay, alkali means soluble base, water soluble base. So this zinc will combine with this only. Okay, so, and forms sodium zincate, Na2ZnO2. This is sodium zincate. You should remember sodium zincate plus hydrogen gas, H2 gas. Name of this is sodium, SODIUM, sodium zincate, ZINCAT, zincate. It is mixed, MIXED, mixed salt. It is a salt only. Okay, but its name is mixed salt. There are different types of salts. Common salt is the you have so many types of salt. Okay, acid salt, basic salts are there, double salts are there, complex salts are there, and mixed salts are also there. In mixed salts you have two different metals. So this is sodium zincate. Name is sodium zincate. So zinc plus NaOH forms sodium zincate and hydrogen gas. In similar manner, instead of zinc, if you take a lead, Pb plus NaOH, then similar type of reaction takes place. Okay, so Pb plus NaOH. See, Pb cannot displace sodium because Pb occupies lower position. Pb is less reactive than sodium. Okay, so this will combine to form sodium plumbate, Na2PbO2 plus hydrogen gas. This is sodium plumbate. Okay, and this also, this is aluminum has no ability to replace sodium. Aluminum occupies lower position, so it combines aluminum sodium aluminate, NaAl2O LO2 plus hydrogen gas. Here you will have 2 because valency of this is 2. Okay, 2 minus, this is 1 plus, and this side is 2 minus, this is 1 plus, and this side 2 minus. Here it is 1 plus, and this is valency of aluminate, this LO2 is 1 minus. So it's the formula of sodium aluminate is NaAlO2. Okay, so this you have, this type of things you have done in study of compounds, the first chapter itself, second chapter itself. Okay, so remember this: zinc plus NaOH forms sodium zincate plus hydrogen gas. Pb plus NaOH forms sodium plumbate plus H2 gas. Okay, aluminum plus NaOH forms sodium aluminate plus H2 gas. Write the name of this compounds also. Okay, now instead of sodium hydroxide, you can take potassium hydroxide also, KOH also. This is potassium hydroxide. Okay, and reaction will be same. See, zinc occupies lower position than potassium. Potassium is more reactive than zinc, so zinc cannot replace this potassium. Okay, it cannot, zinc cannot occupy the place of potassium. So combination reaction takes place. This will combine. So potassium zincate, Zn2Zno2 plus hydrogen gas you will get. This is potassium zincate. Okay, Pb plus KOH, also similar type of reaction takes place. Potassium plumbate, PbO2 plus hydrogen gas. PLUMBAT. Okay, potassium POTASSIUM, potassium PLUMBAT, plumbate. This is potassium plumbate. Similarly, with aluminum plus KOH gives potassium aluminate, AlO2 plus hydrogen gas. This Al2O3 is sometimes it is also known as meta-aluminate. Okay, you can say this name of this compound as potassium meta-aluminate also. Potassium meta-aluminate, ALUMINAT, aluminate. Okay, now preparation of hydrogen gas we have finished. Okay, total we did 8 different types of methods for the preparation of hydrogen gas. First we did the laboratory method for preparation of hydrogen gas, and second we discussed Bosch process for the manufacture of hydrogen gas. Third we did electrolysis, method of electrolysis for the preparation of hydrogen gas. Okay, fourth we discussed preparation of hydrogen gas using metals. Metals means metal, first 3 metals: potassium, sodium and calcium, and cold water. Fifth we did hot water plus magnesium. Okay, sixth we did steam plus below magnesium. What we have, 3 metals. Okay, this aluminum, zinc and iron. Next we did preparation of hydrogen gas from metal and acid, dilute acid. Okay, and the ultimate one we discussed the preparation of hydrogen gas from metal and alkalis, sodium hydroxide or potassium hydroxide. Okay, so you should remember step by step for each process. Okay, now I'll give you one homework. This is your home task. This is your homework. your question is, what will you observe when potassium is added to cold water? What happens, or what you will observe, what you will see when you add potassium to cold water? Next, when you add sodium to cold water. Next, when you add calcium to cold water. And fourth is when you add magnesium, when you add magnesium to boiling water, or when you introduce magnesium to boiling water. Okay, so this is your home task. You refer your book and find the answers from your book. It is there in preparation section only. Okay, preparation of metals, sorry, preparation of hydrogen gas from metals. Okay, so this is your home task. Thank you. This much for today's class. In next class we will continue with this chapter only, and there we will discuss uh, the uses of hydrogen and some special reactions of hydrogen. Okay, thank you.